Hello everyone and welcome back. In this video we're going to take a look at question number 3 on our Galois paper. The even positive integers are listed in order and arranged in rows as shown. So 2 and then 4 and 6 and then 8 and then 10 and 12. So looks like we're going up, there's 4 numbers in the 4th row, 3 numbers in the 3rd row, and so on. So this looks like triangular numbers. And in fact, yeah, it is triangular numbers. Okay, so that's our arrangement. Each new row includes one more integer than the previous row. The last number in each row is the product of the row number and the next largest number. For example, the last number in the 4th row is 4 times 5. You may use this fact without proving this. Okay. Incidentally, the last number, since we're counting by 2s, it'll be 2 times and then 1 number plus 2 numbers plus 3 numbers plus 4 numbers. There's a quick way to add up the first n numbers, and that's n times n plus 1 all over 2. That's 1 plus 2 plus all the way up to n. This formula is quite good to know, and then since we're counting by 2s, we're even numbers, we multiply by 2. So you get n times n plus 1. So row n really should have the last number be n times n plus 1. Okay? So we can prove it. We don't need to, but this is a useful formula that you might want to know for math contests if you plan on writing more of them in the future. It's a nice little shortcut. Sum of the first 10 numbers is 10 times 11 over 2, 55. Anyway, what have we got here? So 2 light bulbs and a written. A, list the numbers in the 7th row of the table. All right, well, let's just work backwards. They tell us what the last one is. 7 times 8, so 56, and then the next number will be 54. How many should be in the 7th row? 7 numbers, so there's 2 of them. 3, 4, 5, 6, and 7. We could even double check what is the number that was the last number of the previous row. It should be at the end of the 6th row. It should be 6 times 7, 42. 44 is the next number, so there we go. In the little box provided in the booklet, I would just probably write that and nothing else. And if you wanted to, you could explain your reasoning. I'm starting at the 56 because I know that's the last number, and I'm working back, and there will be 7 numbers in the 7th row. That's all you would need to say. B part, what are the first and last numbers on the 100th row of the table? Okay, well, for B part, the last in 100th row is 100 times 101, which is 100. The last in the 99th row is 99 times 100. We're just using this fact without proving it. And so the first in the next, that is to say the 100th row, is the next even number, which would be 9902. So I would say 9902 and then 10100. And that's all we need for our answer for B part. But we did explain ourselves a little bit there. And actually, I think that 10 kind of looked like a 6. So let's fix that. There we go. Okay, now C part. So we do actually have to explain ourselves. The last number in row R is L. So it's R times R plus 1. I don't know why they wouldn't just say that. The first number in row R plus 2, so not the next row but the row after, is F. Determine the smallest possible value for R so that F plus L is at least 2013. Won't ever be exactly 2013. Maybe there's a way to make it 2014 or 2016, but it'll have to be an even number because F and L are both even. Okay, so in terms of R, let's say, L is R times R plus 1, whatever that happens to be. F is the next even number after the last number in row R plus 1, which happens to be R plus 1 times R plus 2. So F is R plus 1 times R plus 2 plus 2. So now I can see what L plus F is. Actually, let's write that on the next page. So L plus F in terms of R is R times R plus 1, plus R plus 1 times R plus 2, plus 2. Let's expand this out. R squared plus R squared plus 3R plus 2, plus another 2. So I'll get 2R squared plus 4R plus 4. So I want this to be greater than 2013. Okay, what can we do? Well, it is a parabola in terms of R, so eventually there will be a point if you go far enough out where it crosses through the line y equals 2013. We just want the next value after that. So what exactly could we do? It'd be nice to know what that value is. Can it actually be 2014 or something like that? Well, I don't know. Let's just dump it into an equation. So I need this to be greater than 2013. And what exactly is it that we want, though? The smallest possible value for R. Okay. So this is an integer. 2R squared plus 4R plus 4 has to be greater than or equal to 2014. I just want to make it even so that now I can do this. So now I'm going to divide by 2. And then, I doubt it, but does 1005 have two factors that are close enough? So 1005, taking a 5, you can divide that by 3. 67 is prime, so no, I don't get to be that lucky. Act of pure optimism, thinking that would happen. So what can we do here? Well, actually, you know what I could do? I'm trying to avoid doing something like a quadratic formula. So, well, I will leave that there where it was, actually. But what I'm going to do is I'm going to say add 1 to this side, and then that becomes 2006. So let's say R squared plus 2R plus 1 has to be greater than 1006. But this over here is R plus 1 squared. So can I think of a square that's greater than 1006? And absolutely I can. What's the nearest one? It should be, I want to say 33 squared. But the easy way to do this is just to square root 1006 and see that that's, 31.7. So the next square would be 32 squared. Actually, let's continue this on the next side. R is an integer. So R plus 1 squared is a perfect square. The next perfect square is 1024. So if R plus 1 squared is 1024, R plus 1 would be 32, so R will be 31. And that should be the smallest value. Yeah. Is there any way we can... Well, I can check this myself by saying something like, these values here are only ever increasing. So the first values on each row are always increasing, like 2 and then 4 and then 8, and then this is definitely increasing, but so are these numbers. So if I pick a later R, so I've got 31. If I pick an R that's further below, its L and F will definitely be bigger than the L and F coming from R equals 31. So the only question is, will R equal 30 work? And I'm pretty sure we can verify that no. What was our formula for L plus F? 2R squared plus 4R plus 4. So if I work that out, this should be greater than 2013. So 31 times 31 times 2 plus 4 times 31 plus 4. That's 2050, but if I take a look at 30 squared, it should not be enough. So 900 times 2 plus 120 plus 4. 1924, so 31 really is the right answer. This is just me checking it. I don't actually have to include that in the question. I've explained my work here with the inequalities quite nicely, and I avoided having to do some sort of quadratic formula with the parabola, although you probably could do that just fine. All right, so that was the last bit, right? That was 3C. Yep. So we've got one more question to go, and that'll finish off the 2013 paper, and that's question number 4. Join me for that if you would like to in the next video.